All right. Okay. Okay.
Hi, thanks.
All right. It's recorded. Hello, everyone. Welcome to Karmada bi-weekly English meeting. And my name is Ying. I'm a software engineer at Zendesk. Our company is adapting Karmada to use Kubernetes clusters. I'm not part of Karmada team, but this time I'm so excited to be your host of the meeting today. All right, I would like to draw your attention to our agenda. So today will be, can you see my screen? There will be two proposals from, both of them are from Weijiang. The first one is propose cluster proxy without being aware of the member cluster. And the other one is propose cross-federated HBA to scale the workload at a specified times. So before we get started, I just want to some logistical reminders. The meeting is being recorded and will be available on YouTube Karmada Community channel later. Please do take a moment to mute yourself, or you'll be muted by the power that by the host, me, and to be that is to keep disruption to a minimum. And if you have any topics outside of this agenda, just have them on this list, and we will have them for the end. If you have any questions during the discussion today, please raise your hand reaction, or just turn on your video, raise your hand so I can see your screen. And also feel free to share your comments and questions in the chat anytime. So, okay, all right, let's get started. So Wei, over to you.
Okay.
Present, or you good?
So, I think I can just share my screen.
All right, let me stop sharing.
Okay. Window share. So now, can you see my screen now?
Yes, I can.
Yes, thank you.
Oh, okay. Okay. So this proposal is about, the index asked about this before. So the background is clear. So Karmada now makes a unified entry to quarrel and modify multi-cluster resource, and without being aware of the member cluster names. Also, additionally, any such operations must adhere to the RBAC configuration set in each individual member cluster. So this is a core background. And now there is two proxy, the current situation. First one is a cluster proxy. Here is a command to query node resource. From the URL, you can see you need to know where is the cluster, what's the cluster name. So then you can specify the parameter here, then query node resource from the target cluster. The second is search proxy. But search proxy, the feature aims to build a cache to store arbitrary resource from multiple clusters. So these resources are exposed by search proxy REST APIs. So if users has access privilege to search proxy, they can directly access the cached resource without routing their request to the member cluster. So if a secret is cached in the command control plan, but the user in the member cluster cannot access it through API server due to the RBAC privilege limitations, they can still access the secret through command control plan. This is a limitation. So this feature is designed for administrator who needs to quarrel and view their resource in multiple clusters, not designed to the end users. So if exposing this API to the end user, we could end user to be able to view the resource that do not belong to them for multi-TNet system. So, sorry. So to solve the problem, I want to propose an enhancement for cluster proxy. You can use like this, the kubectl with this URL append to the kubectl. Then the root request will go to the member cluster, the target member cluster. So it supports Quarrel member cluster resource without being aware of the member cluster. Second is compatible with the native usage of kubectl, get, list, describe, update, or delete. The usage is very simple. You just append this API cluster.karmada.io v-alpha-e proxy to kubectl. Then you can use kubectl and this kubeconfig to acquire resource, modify resource, or any other operations like the native usage. So this is the first thing I want to propose. Okay, is there any questions?
Hi,
about
please back to this last. I think in the picture, control get and list the results against the Karmada aggregated API server. I think this should be Karmada API server, right?
Yeah, it will first the request will go to Karmada API server, then the routing to aggregate API server, then go to member clusters.
Okay.
Yeah. So with this feature, I think the problem could be solved. First, the core thing you want is first not aware of the member cluster. Second is the native usage like kubectl. And third is adhere the RBAC configuration in member cluster. The three conditions could be satisfied with this feature. Okay, if no more questions,
I see Ying has raised her hand.
Sorry.
So, no worries. So we have a like quick silly questions, and if we adopting this aggregated cluster proxy, are we still like able to identify which resources are coming from which cluster, which member clusters? Like for example, I'm using a kubectl like get on like pod, and does it gonna return all the pod in the member clusters, or
it will like if you query a specific pod, it will query all the member cluster and from member cluster and aggregate them and return it. Like the way.
All right. Is there a way that I can specify a member cluster? For example, I only want to know from how many pods, for example, like how many pods are existing in the member one in the namespace. Like
if you want, I see. If you want to, specify which cluster, you can, you can specify the URL in here, specify the cluster name, then you can cover the specific resource in specific cluster.
This part should be part of the kube config.
Yeah, should be a part of kube config.
Oh, okay, gotcha. Cool. Yeah, thanks.
Yeah. Okay, so next.
Hi, Vijay. Can you hear me?
Hi.
Yeah, I have a question. In your enhancement URL, you seems the class name is has been removed. I think this class name is necessary. We need in implementation, we need this in this name.
Why I deleted it? Because for the, like Quarrel pods in all namespaces, the URL would be API VE pods. If you want to specify specific namespace, it's like API VE of V1 namespace default pods. So I think we should follow the format like of the KBase Kubernetes.
Sorry, I think the clusters and the class name, those two fields need to be heard when we publish the URL in implementation.
Yeah.
If we removed those fields, I think there will be some problems.
I get it. Yeah, I think we can, after we will give a proposal and we'll dig in more information about this, how to implement with or without these class names.
Okay, thanks.
Yes, I think we can have a demo for this before moving forward.
Yeah.
Okay.
So this is just the difference of whether or with or without this cluster in URL. Okay, so next I want to introduce the new feature in Karmada new version, federated HPA. So it's simple. It just scales down the workload replicas across multiple clusters with the aim of automatically scaling the workloads to match the demand. From the picture left, you can see there is a pause in cluster 1 when the load comes. Karmada could scale workloads across clusters. Then you can see in cluster 1 and cluster 2, the pods both be scaled up, like scale across multiple clusters. The implementation overview is quite simple. First, it queries matrix through the matrix API with a label selector. Second, Karmada API server gets the matrix API query and it will route it to Karmada matrix adapter. Then matrix adapter will query matrix from target cluster and aggregate them and return it. The HPA controller will calculate the desired replicas based on the matrix and scale the workload directly. Then Karmada scheduler will schedule the replicas to the member clusters. So the implementation is quite simple. Just it's work like the HPA in single cluster. So here is a demo. You can see the spec is almost same as a single cluster HPA, like scale target drive and min max replicas and matrix. Just the API version and kind is different. So you can migrate your HPA to multi-cluster HPA very fast and simple. So, but what next? There is some, here is a user story. Like I, as a cluster administrator, I know there will be sudden peak traffic every day at 9:00 a.m. So if we use HPA, then the load peak comes, but the needs time to scale up. But when the replicas is not scaled up, the service may be unavailable for some users. So I want to scale up the related service in advance, like 30 minutes ago before, to meet the sharp load peak, ensuring service available when the load comes. So here I want to propose Cron federated HPA to handle this situation, like scale up the workloads at a specific time. The proposal link is here. You can, any comments and suggestions is welcome. Okay, here at the right is the overview about this implementation. There is a controller cron HPA controller, it watched the cron fidelity HPA resource and updated the fidelity HPA or scale up or down the workloads reft directly. Then the workloads will be scheduled to different clusters. So here is a demo about this implementation. You can see we can, like we said before, 30 minutes in advance. So we can define 830 to scale up 1,000 replicas to handle the sharp load peaks. Then after the load peak is gone, I want to scale down to save the cloud cost. Here we can line then 10 o'clock, the load peaks gone, and we can scale it down to 1 like this. It's very suitable for some like Black Friday or double 11 Singles Day. Yeah, that's all. If there are any questions about current fidelity HPA. Okay, if no questions, that's all I want to share. Thank you, everyone.
Right. Thank you, Wei, present those two proposals. And does anyone has any questions? Not only for those two proposals, any other questions? I'm gonna take this silence as a no.
Actually,
Okay,
I have
sorry.
a question. Sorry.
Yeah, go ahead. I can hear you.
Yeah. So we are in the phase to consider using Karmada, but we have a few concerns, basically from our internal requirements. So one of the concern is the disaster recovery of Karmada cluster. So for example, how let's say the admin cluster is at one data center and it goes out, how easy or is it able to spin up in another place? Or say whether we can have two admin clusters coexist to back up each other?
Let me try to understand your question. You are asking how to allow two Karmada instances to back up each other, right?
Yeah, or it can be a general question like Karmada cluster is managing multiple subclusters. Yeah. Let's say we have another controlling cluster to manage other resource or even competing resource. Is Karmada okay to coexist with the other control?
I think so. Yeah. You might be asking the question that some resources are managed by, for example, managed by your legacy system, and some resource is managed by Karmada. Can they co-work together, right?
Yeah.
So, I think so.
Yeah, for example, I think one of the highlights of Karmada is manage quota stuff. Let's say we already have something to manage quota, and we just use Karmada to manage user traffic. Is it able to do that?
Yes, I think so. But just a reminder, if you for single resource, if you use Karmada to deploy the resource, you shouldn't manage the resource by other system. Yes, but for different resource, Karmada can work with other system.
Okay, so for one type of resource, we expect only one Karmada cluster to manage it. That means we
Yes.
cannot have, let's say, two Karmada cluster connect to the same set of workload clusters. So
yes, we.
so the
Yeah.
admin back up each other.
Yeah, for this scenario, I think two Karmada will have a conflict to manage the same resource.
I see. Then what if the Karmada cluster is down? Is there any workaround or playbook?
Yeah, I think this question is quite similar to Kubernetes cluster. People might ask, what if Kubernetes cluster down? Now, Karmada is supposed to deploy the Karmada components in multi-instance, like to provide the HA. So if you deploy Karmada instance into one cluster, if the cluster down, I think you are not able to manage the resource from Karmada anymore. But the resource already being deployed to memory cluster will not affect.
So it's not destructive to workload cluster if admin is done. Then
yes, exactly.
Then is it possible to quickly spin up another admin cluster to take over the work? Is it possible?
For now, we don't have such practice, but it's a quite interesting question. I'll think about it.
Yeah, thank you. And also maybe it's a stupid question to understand Karmada overall. So I saw some intro of Karmada say it is able to handle unfederated CRD, but last time our community meeting also talked about supported third-party CRD. I'm
Yes.
wondering what's the difference, like why we have the concept of third-party CRD while it's flexible enough to handle all CRD.
Sorry, I don't quite get your question.
Yeah. So just try to understand what's the federated CRD concept versus the third party CRD we talked about last time.
Yeah, I think we don't have the concepts of the federated CRD. Karmada accepts all CRDs, and we don't have a federated CRD like KubeFed project. Yeah, at the last community meeting, we talked about the resource interpreter. This resource interpreter framework aims to interpret the CRD structure so that Karmada can knows how to propagate the CRD to member clusters.
Okay, so in order for Karmada to schedule things here and there, it has to understand the CRD via the interpreter.
Yes.
So if we have our own CRD, we need to come up with similar YAML or something to help Karmada understand it for all the resource touch. Okay. Right.
Yes.
Well, thank you. I think that's my question at this point. Thank you so much.
Okay.
Right, thanks for asking the questions, and feel free to reach out to Karmada team in Slack. There is a channel in CNCF and name Karmada. And also feel free to submit pull requests or issues in the Karmada repo. Does anyone has any other questions? Only at once, twice. Okay, so we're done like 2 minutes early. Thank you so much for your present and participation. And the next meeting will be in 2 weeks from now. It's gonna be June 27th, same time. Okay, thank you all again and see you next time.
Thanks. Thank you all. Bye.
Bye everyone.
Thank
Have a great
you.
rest of your day. Bye.